So before starting with any pattern, let us start with a common example. Typically, you would see these kind of examples in any web-based systems or even in non-web-based systems. But let us look at a web-based version of this particular example. Suppose you are going to build a web-based software system, and suppose that this software system is supposed to display the grades of different people, and you have the database which is going to store the grades of different students, and these grades are basically A, B, C, D and F. And what you want to build is a kind of a dashboard on the UI on the browser, basically, so that one can see the different statistical results. So for example, in the database there are students who have some students have gotten A, some have gotten B, and so on. And what you want to show on the browser is essentially this pie chart, which shows what percentage of the students got A, what percentage of the students got B, and so on. You would also like to show a histogram, and you would also like to show a table showing the percentage. Suppose you were to show all the three. Now all the three information, which is pie chart and bar graph, histogram, and as well as the table, they're all driven from the same data, which is this blue color data, which actually has this content that grade A is 5, grade B is 15, grade C is 50, grade D is 25, and grade F is 5. From these data you would like to create three different views. So such an application essentially retrieves the data and displays it for the user. However, in a general scenario, the user might, in this example of course it just shows it to the user, but there might be a scenario where, and that's a quite common one, user would change the data after user sees the data, changes the data. Then the system goes back and stores the updated data in the data store. So it's going to be a two-way communication. So let us look at the context and the problem. The context here is that the interactive application will have a flexible human computer interface. Problem is that because the flow of information is between the data store and the UI, essentially what's happening here is that whatever is there in the data store, in some form or the other, that data from the data store need to be shown in the UI. That's the problem. But the thing is that because it is essentially showing the data on the UI, and then if the user makes some changes, that should be reflected back to the data store. The simplest and easiest and shortcut approach is that one might just want to combine this data and UI and essentially want to reduce the coding, and even in fact that improves the system performance, meaning that the UI contains the information and the logic to retrieve the data and show. That's the simplest way to do it. However, that's okay for simple application, but for a really business critical application, large application, this approach is not going to be sufficient. The major problem is that the UI tends to change more frequently than the data storage system. Another problem is that in a complex business application there are really complicated business logic, and that needs to be separated, that needs to be changed. However, if we take the shortcut approach, then everything gets mixed up. So the constraints are, or the forces are, we need to represent the same data in different manner. Then as soon as there is a change in the data, we would like to reflect that data change in the UI, meaning that if, let us say, someone changes the grades in the data store, I want that information to be reflected back to my UI. Now UI is basically a very different element altogether. As I said earlier, changes are very frequent. It is more than the data and business logic, and one should be able to test the UI part only. Not only that, there are more practical problems, basically project management problems, that people who are expert in UI are typically not the same person who can do the coding for database or the business logic. So these skill sets are very different. So if we mix everything, then essentially it's a problem that either the HTML page designer needs to know this business logic, or even coding, how to code that, or how to write code to extract data from database, or the people who are expert in database design or even server-side coding, they need to learn the UI. Otherwise, it becomes a real mess. Another thing is that the look and feel changes, even device independency or device dependency, shouldn't really affect the core application. In the web application of today, what typically happens is one UI action can trigger many processing. It can actually initiate a workflow. It can cause multiple requests to be sent to different servers, and it also requires that data from different sources need to be collated into one and then presented to the UI. So in view of that, what this particular very popular pattern says is that you need to separate the view and the data, as well as the logic to manipulate the data as well as the view. That should be all kept separate. Now this particular pattern is called the model view controller pattern, or MVC pattern. It's very well used, and I'm sure many of you have heard this term called MVC, but let us understand how MVC works here. So here there is an event that basically comes to the controller, or the controller receives an event. These events are nothing but UI events. For example, keyboard, mouse clicks, these are all events. Ideally they all pass to the controller. In the case of web-based application, essentially button clicks and so on, they're all events. There could be multiple controllers. However, each controller interprets the input and basically takes an action. View is essentially the management of information. In fact, how do you display the information? So view is about managing the displays, how you are going to present the data. It shouldn't be, that's it. It should get the data and then it should basically know how to present it. So in our example, view is nothing but those pie chart, bar graph and tables. So it should have the logic to refresh the pie chart, bar graph and so on. Even it can have animations and things like that. The model part essentially captures the data. It sends the data to the view. Not only that, it responds to controller for changing the data. So model encapsulates the data. It also handles the change, and then it informs the view. That's how it works. So let's look at the class diagram for model view controller. If you notice, I have used an interface called observer. Now model view controller is very similar to, or in fact it's the same as what is called publish and subscribe pattern, or observer pattern. So observer pattern is essentially a design pattern which is supposed to be at a lower level, but MVC is more specific to UI related design. So basically MVC adopts this observer pattern. Let's see what MVC is here. So we have something called an observer, which is an interface, and this observer actually has a method called update. So both view and controller implements this interface called observer. So view actually has the model part. View actually has association with the model. We'll look into that later. But let us look at the other parts of view. View basically has methods like initiation, then create a controller, activate it. It has this display mechanism, update mechanism, and so on. The controller, on the other hand, it implements the observer. Therefore, it also has update. It has to implement the update method. Plus, it has its own init method and handle event method. Then there is this model class, which actually contains the data, set of data, plus it maintains a set of observers. It has a set of methods like attach an observer, detach an observer, notify an observer, and so on. Getting data. So this attach and detach observer are the methods by which a view or a controller registers itself with the model. So when the user makes a change in the UI, the request comes to the controller. In fact, that's processed by handle event. Then the controller interprets the change, then it informs the model for the change. Then model makes a change in the data, and then model notifies all the relevant views regarding the change. How does it know all the views? It basically goes and looks at the observer set, and then for all the observers it notifies. And view gets the latest data upon the notification. View is actually inactive in that sense. View is really not aware of the fact that the data has changed. So when it is notified by the model, then it basically goes and gets the data, and then it updates the display. So these are the 5 steps. Let us look at the sequence diagrams. So let's look at the scenario that user is maybe pressing a button on the UI web page. That's an event that comes to the controller. Controller in turn calls a method called service, and then if you remember that the controller also controls the model, so therefore it calls the model. So model, what it does, it makes a change if it is required in the data. Then it performs something called notify. Notify is nothing but a notification of all the registered views, and in that process it basically makes a call called update to the view. Remember that view is basically an implementation of observer interface. So when model goes to its own set of registered observers, it just takes one observer after another, and basically it keeps calling update method. That's it. It doesn't do anything else. It just goes and takes an observer which is already registered with it and makes the update call. Model is not even aware that who has implemented this observer interface. Now when this update method is called, that in turn goes to view, and view in response to update method, it makes a call to model saying that give me the data. It can ask multiple data that's needed, and then it basically changes the display. Model can also update the controller, because controller is also an implementation of the observer interface. So when model makes a call to a controller saying that update, in response to the update method, controller again goes back to model asking for data. Obviously controller is not going to be responsible for any display, but it might just get the data for any other processing. So how are you going to initialize MVC? In the main program, you create a model, then you create a view, then you call init method of view, which in turn basically attaches a model with itself. Then so it's very important that the model is created, then the view is created, then to the view the main program says init, and then this init method is invoked in the view, and view then attaches the model with itself. Then view creates a controller, and when this controller is created, after creation of the controller, it again calls init method of the controller, and in response to that, controller essentially attaches the model with itself. So if you look at the init method, it basically, the view basically passes the handle of the model object as well as a view object as a parameter, as 2 parameters. So controller knows these 2 parameters and then essentially attaches itself. Now what does this attach mean in these cases? For both view and controller, attach means that it tells the model that please attach myself with your or into your observer list. So what happens is that when this attach method is called, model essentially takes the handle or takes a object ID or object reference of the caller, in this case the view and as well as the controller, and basically puts this object ID or object reference into its own list, so that later on it can refer to that list and then notify. So this is how it's a bit indirect way. So to repeat this whole process, when a view is created and views and either view or the controller after the creation, when init method is called, as a part of the init method, view and controller essentially registers. View and controller both register themselves with the model, so that model can later on call them when it needs to notify. So after this, the initiation part is over. Then main program basically starts the event processing, and that might go in a loop. In fact, that could be infinite loop. It will continue, it will wait for an event to come, and then it will invoke the controller. There are other scenarios that one may need to update the display only, no change in the controller. In that case, one could basically short circuit it, and such model and view and controller, all the three elements are not required. When just updation of display is required, then basically controller can directly call the view. When the system exits, then sequence of deletion or destruction of objects need to happen. That I have not explained, but essentially in the main program, these views and controllers need to delete it, so that all the objects that it is holding goes back to the heap. Let's look at how one can implement model view controller. So there are 5 steps here. Separate the human computer interaction from the core functionality. That's the first thing. Second step is implement the setup of MVC, which is the setup part. Then design and implement the model, design and implement views, design and implement controllers. So first you separate which part need to be human computer interaction, which part need to be backend. Then set up the MVC, then create model, create view, create controller. 5 steps. So in the initial part, a separation of human computer interaction, this need to be done by the architect by looking at the requirement, analyze the requirement, analyze the core functionality, and then there is no automated process. One needs to really read that requirement and then separate the core functionality. Then next step is decide which functionality need to be exposed to views and which to be exposed to the controller. Decide how many views you need, how many controllers you need, because depending on that you need to implement those many controller classes. Then setting up of MVC. Write the code that calls the model initialization method, which I actually showed in the second sequence diagram. Then write the code to call the view creation. Then write the code to start the event processing mechanism, that is setting up of MVC. Design the model. Here what you need to do is that you need to encapsulate the data and functionality that accesses the data. The whole purpose of model is to bridge the core business logic of the system with the UI and things like that. Note that the system has much more complex business logic, which is not really related to the user interface, or which need not even be shown to the user. So those part really does not come into picture when we are talking about interactive system and model view controller. So model deals with the data which gets changed and which need to be reflected back to the UI, only that part. So it really need not expose the entire business logic, and it really need not interact with the entire business logic. As I said earlier, this is nothing but a publish and subscribe design pattern. Here, as a part of the publish and subscribe design pattern, important part is to basically have a registry. So here in the registry there are references to views and controllers, which are basically observers. So model thinks that these are nothing but a set of observers. Now the model needs to provide APIs for an observer to subscribe or unsubscribe, essentially attach and detach. Implement the notify mechanism, which will be called every time other parts of the system change the model state. So model essentially encapsulates the data. Therefore, whenever the data is changed and when the data needs to be shown to the user, and that data is changed, not all the data but the data that need to be shown to the user, and with that, when that is changed, then the model needs to invoke the model needs to call the notify method. So every time the model's state and the data is changed, model needs to invoke the notify method. The notify method in turn calls update method of each observer, which is either a view or a controller, which we have already explained in the sequence diagram. Then let's look at view. View is basically the presentation part. Design the appearance of the view, how it should look like, color, fonts, placing of different elements, what kind of information need to be presented. In fact, each important data entity should have its own view. Each view may have its own controller. Sometimes a set of views can also share a controller. So view creates a controller using a factory method or factory method design pattern, which is basically make controller. So factory method is a design pattern which we will learn later on during the design pattern series, lecture series. But just notice a few things, that here this architectural pattern is making use of design pattern, and in another scenario, MVC itself is a design pattern or is a usage of the general purpose design pattern called publish and subscribe. So in a sense, design pattern sometimes becomes more generic and architectural pattern becomes more specific. This is a good example of that. Publish and subscribe is a design pattern, but MVC is an architecture pattern, which is essentially an usage of publish and subscribe. Anyway, so view basically creates its own controller using the factory method, and view exposes a method for the controller to use directly, bypassing the model. So remember where a scenario that I have talked earlier, that there may be a case where just the view needs to be updated. Then instead of going through this more complicated sequence of going through model first and model informing the view, one can short circuit that, bypass that. So which is why view exposes a method for the controller to use directly. So controller can directly calls the method to the view to update some data without having to involve a model. But these things need to be used only when the modification is simple. In fact, the controller should call view bypassing the model when model's state has not changed. So example is that, let us say you have those grades, and then in the UI you have a pie chart to basically show those grades. Then suppose you want to show the same data in the form of a table. Then because the model's state has not changed, then there is no point routing this request through the model. Controller can directly call the view to create a table and represent the same data. So view basically needs to implement the update method, which will essentially retrieve the data from the model and present it on the screen. Then initialization part, register with the model and set up the relationship with the controller. So another important thing is that look for efficiency of fetching the data from the model to build the view. View to decide based on the changes. So for example, if draw needs to be called, view should decide based on what kind of changes are there. So in other words, whether the draw method needs to be called or not, or any other method needs to be called or not, that is dependent on the amount of change that is there on the data set. So view needs to decide that and make an efficient data fetch. Design and implementation of the controller. Here the initialization procedure, where the controller needs to be attached to the view and the model, and in fact this initialization procedure, as I explained earlier, it basically need to enable the event processing. So the necessary attachments, registration need to be done with the model. Then it needs to subscribe to the change propagation mechanism, set up the relationship with the view so that it can call the view directly. Then it implements the event processing. Very important, because controller is the module, the class, which is going to receive the request from the user. So it should accept the user input as events, and event delivery to the controller is typically platform independent. So events translate into request for the model or the associated view. Controller behavior is dependent on the state of the model. Depending on what state it is, it needs to take the action. Controller also needs to implement its own update procedure, because controller is also an implementation of the observer interface. There are different variants. In fact, the document view that was there in Microsoft Foundation classes, and in fact that was there in earlier MFC design classes. This is nothing but model view controller, where the model is a document, view is of course a view plus controller. One important feature is that this loose coupling of view and the controller enables multiple simultaneous as well as synchronized but different views of the same document. Very important that view and controller, because they're loosely controlled, then for the same document, which is the model or which is the data, one can create multiple views which can basically show the same thing in different ways, and at the same time they're all synchronized in terms of the data. As soon as some data in the document changes, all the views change automatically and in fact simultaneously. Let us look at usage of MVC. In fact, MVC is a pattern that was there for a long time. MVC is quite relevant even today. In AJAX based applications, MVC is heavily used. AJAX based web application essentially is a departure from traditional thin client approach. The traditional web based UI is basically a thin client approach, where the browser sends HTTP GET POST request to the server. Entire web page is then refreshed. There could be client-side JavaScript, which is used for typically field validation, and one request from the UI can result in retrieving data from many servers. That's a typical pattern of any 3-tier or 2-tier client-server application. AJAX, when it runs on the browser, it actually makes an asynchronous call to the server without really refreshing the primary HTML. And because it can do this asynchronous calls, many such calls, and may change some part of the HTML, this whole UI experience is no longer a thin client. It actually provides a much richer user experience. So this is a schematic diagram of AJAX. On the browser side, on the top, there is a rich UI comprising of the JavaScript and HTML. Then there is something called an AJAX controller, and AJAX controller, which is sitting on the browser or inside the browser, is interacting with the HTTP server plus the app server and database. Essentially, it interacts with the HTTP server, and that in turn interacts with the application server and so on. The entire communication happens through REST, and REST call is a call which comprises of the JSON format request, which is sent over HTTP, and the response comes back from the server to the UI as an HTML plus JavaScript code. So AJAX calls REST, makes a REST call, and the response can directly update the UI. Now, the model of HTTP server is that it expects the request to come serially, and it needs to process them one after another. So what AJAX does is it basically queues a set of requests in its own internal queue and then sends them one after another. AJAX actually can provide a rich user interface over the browser. In fact, if you look at Google Docs or Google Spreadsheets, it basically gives you almost like Office environment over the browser. It's a very rich user interface. This is possible because of this AJAX mechanism. Many SaaS cloud applications today make use of AJAX. In fact, AJAX is actually a perfect example of MVC pattern. So let's look at AJAX and MVC together. We have the client side and the server side. At the client side, we have got the rich presentation layer. Then the client side, there is the AJAX controller, and on the server side, there is server side controller. Then there is a business logic and the data access logic. The interaction happens through AJAX and the server side through REST call. So what is a controller here in this MVC pattern? Controller is actually split between two parts. One part is with the AJAX and the other part is with the server. Traditionally, Struts framework, Spring framework, which has been used for MVC, that still resides in the server side, which decides more complicated UI flows, HTML presentation, and so on. And quick calls, some part of the HTML page needs to be modified, some part of the browser needs to be modified. Those kind of things are handled by AJAX. It is possible, because of this AJAX and asynchronous call, now it is really possible to reflect the changes in the model immediately, unlike a traditional web application. So in the traditional web application, if the model, which is not in the client but in the server side, when the model changes, it does not get reflected to the view immediately, because unless the browser makes a call, it doesn't get updated. So browser needs to make a call in the traditional sense. Here, because of this AJAX model, when there's a change in the model, then AJAX essentially, because it works as an asynchronous approach, it gets a notification, and then essentially it internally invokes in fact it gets a notification from the model part, and in fact the model can also notify the view directly, and the changes can be reflected to the view almost instantaneously, which is why you see that today in many of these web pages, some part of the web page gets refreshed quite frequently, while the other parts remains static. So in fact, for this purpose, to actually achieve this, one need not really refresh the entire HTML page. View is the traditional HTML plus JavaScript. Model is a business logic that changes underlying data, and model functions can be replaced, modified, maintained without impacting the UI or the controller. What are the benefits of MVC? You can have multiple views of the same model. One can have views which are synchronized. As soon as the model changes, all the views will get the change. One can plug new views. One can exchange the look and feel, just modify one view with another one. This basically has become a very powerful framework. However, there are liabilities as well. It is certainly quite complex to implement a UI using this model view controller. It is very non-intuitive design. There is a potential of excessive number of updates that can make the whole system slow. Then this connection between view and controller, that's also becomes a liability. View and controllers are getting quite tightly coupled with the model. In the view, the data access is not very efficient. As I said at the beginning, that the most efficient way of accessing data and show it is just directly get the data and then show. So the inefficiency is certainly there. Then with modern user interface tools, in a tablet or in different devices, using MVC is not very easy. I'm not saying that one should not use it, but I'm saying that because of the inherent complexity of MVC, using MVC for these are not easy at all. So that is all for now. We have covered an important architecture pattern called MVC, Model View Controller Pattern. In subsequent lectures, we will continue with interactive systems, and we'll look at some other patterns as well. Thank you.